An element delta L equal to delta xi is placed at the origin and carries a large current I equal to 10 amperes as shown in this figure. Okay, this is a delta
Yes.
x element, a length, elemental length. Okay, xi means xi in the sense along x direction it is acting, I is a unit vector, is placed at the origin and carries a large current I equal to 10 amperes. What is the magnetic field on the y-axis at a distance of 0.5 meter distance? Okay, at a distance of 0.5 meters. Full stop. The elemental length which is given here delta x equal to 1 centimeter. So over here we need to find the magnetic field, right? So we need to find the magnetic field in the sense what we have to do. Remember how what we need to do in the sense just first we need to understand this question is belonging to the which topic. With respect to the elemental length, we are going to find the magnetic field at a point, that too at a distance, in the sense that is completely related to the Biot-Savart law. Okay, so we know that Biot-Savart law. What is the Biot-Savart law? We can write dB equal to mu naught by 4 pi. In terms of vectorially, you wanted to write in the sense dl uh, cross r we will write. In terms of magnitude, mu naught by 4 pi into I dl sine theta by r square we will have. So, what are the given things we are having? dV is a magnetic field which is finding due to the elemental length dl equal to x. dl equal to delta x, which is equal to 1 centimeter. Right? Then next, 1 centimeter, we will write whatever the units are given that we will express in terms of meters. 1 centimeter is equal to 10 to the power of minus 2 meters. Is it right?
Yes,
Then
sir.
mu naught by 4 pi can be written as 10 to the power of minus 7. I equal to, it is mentioned 10 amperes in the question. Excuse me. Next, at distance 0.5 meters, they have mentioned in the same system. So if you substitute this all, just we have to do calculation 10 to the power minus 7 into 10 into 1 10 to the power minus 2 dl in sine theta. Since they are shown 0.5 meters along y-axis, in the sense completely it is 90 degrees angle here. Okay, in the question. So sine 90 value gives us 1. Now r square in the sense 0.5 whole square. What I am doing 0.5, 5 into 10 to the power of minus 1, 25 into 10 to the power of minus 2 I am writing. Is it understood?
Yes,
0.5
sir.
I have written like this. Now, simply if you calculate 10 over minus 2 minus you get cancelled and you have 10 and minus 7 1 is cancelled. So dB equal to 1 by 25 into 10 over minus 6 you are having. So 1 by 25 can be written as in terms of what? How can I write? 1 by 25 I can write I equal to 10 is over. 25 can be written as
0.05.
4.
No, 0.04.
4.
Yes, sir.
0.04 into 10 to the power minus 6. Further, it can be written as, if I'll remove the decimal, if I'll shift the decimal this side, I can write
4
4
into
into 10 to
10
the power
raised
minus
to
8
minus.
Tesla. This is in which direction? Here direction is a matter. What is the magnetic field on the y-axis at a distance of delta x equal to 1 centimeter is a given question. Now, in which direction it is possessing? See, always dl cross r we will write in a vectorial, right? Cross product of two things. Here dl cross r when you are taking, dl means gives us delta x I, right? And r is given along y-axis in the question. Along the y-axis given in the sense y into j cap I can write. Therefore, from this, if you keep aside delta x and y, I cross j always gives us k. So, the direction of the magnetic field is in the direction of k. Means it is like this in this direction. K in a sense, if this is j, this is I, this is k. These are the unit vectors like this. I, j, and k. Right? So I cross j gives us always k. There is a product. I cross j gives us k. K cross I gives us j. Okay? And k cross j gives us minus I. Reverse direction basically. Got it? Are you following? So
Yes, sir.
this is a cross product properties. Okay? So by this way we can understand in which direction the magnetic field is acting. Means this is a dot point is showing that perpendicular to the page in the z direction. That is indicating with the unit vector k. Okay. This is one of the conceptual problem with respect to the direction we can understand. Right? So this one more important problem which is belonging to the galvanometers which we need to discuss is mandatorily. Uh, why I am telling this is compulsory. Most of the times, one question has given in the case of conversion of galvanometers. Okay, to get
Yes,
this, I'll explain the question first of all to you. The question has given here with respect to conversion of galvanometer into voltmeter. First, the other day we have given, we discussed about the formulas, right?
yes, sir.
Yeah. Question is, will be bigger, not so. Yeah. An ammeter of resistance. An ammeter of resistance. Resistance 0.80 ohms. Can measure currents. Can measure currents. Currents up to 1 ampere. 1 ampere. First one. What is the shunt resistance? What is the shunt resistance? Shunt resistance to enable the ammeter ammeter to enable the ammeter to measure current up to 5 amperes, up to 5 amperes. Question 2. What is the combined resistance? What is the of the ammeter? Combined resistance of the ammeter and the shunt and the shunt. Now, an ammeter of the resistance 0.80 amperes. So RA equal to how much? First of all, are you aware of that? What is a circuit? An ammeter of resistance 0.80 ammeters can measure currents up to 1 ampere. 1 ampere. What is the shunt resistance to enable the ammeter to measure current up to 5 amperes? Means the shunt resistance in the sense whatever while you are converting the galvanometer which you are connecting parallelly to the galvanometer. Okay, if you convert to
Yes.
the galvanometer into ammeter, you have to connect the resistance that is a shunt. Therefore, galvanometer resistance decreases. Galvanometer acts as a ammeter. Right. This is the circuit of that. Right.
Yes, sir.
For this, we are connecting like this. This is a shunt. This is a galvanometer resistance. Ig. This is I. Now, the question is, what is the shunt resistance to enable ammeter to measure the current 5 amperes? Question 2 is, what is the combined resistance of ammeter and shunt? Combined resistance of ammeter and the shunt. First of all, for the first question, if you go, the total current is to get is 5 amperes to enable 5 amperes. To enable 5 amperes, how much shunt is required? So we have a formula. What is the formula? Shunt resistance is equal to means this. Okay, is equal
Yes,
to
sir.
the amount of current which is flowing to the galvanometer by the total current minus the current which is passing to the shunt. This is the total current entering here. Okay. Then here it
Yes.
is divided as Ig and Is. So I minus Is. So I minus Is into we have what else more Rg. Who is the Rg? The resistance to the galvanometer or galvanometer resistance we can say. Now what I am doing, sorry this is not Is, I can write already. uh, this is I minus Ig. This is divided now.
Yes. Yes, sir.
Otherwise here I minus I. Otherwise Is directly I can write, but since Is I don't know. So is equal to shunt resistance is equal to Ig. How much they have given? The current flowing to that 1 ampere.
1 ampere.
1 minus
5.
total current is 5 amperes. 5 minus 1 into Rg. Rg is 0.8 ohm. 8 ohms. This gives us S equal to 1 by 4 into 0.80 or 1
Zero
by
point 2.
2. So is equal to 0.2 ohms is the shunt resistance. Means this much resistance is required for the shunt to enable 5 amperes current. Okay.
Yes, sir.
Now, same way, if with another color, I will do the second question. So here only I can complete. What is the combined resistance of the ammeter and the shunt? Combined resistance in the sense, what is the total resistance? Now, to the galvanometer, how much resistance we set? 0.8 ohms. And to the shunt, how much it is set? 0.2 ohms. Now,
0.2.
combined resistance means what you have to do? You have to uh,
And
add up those two. Add up in the sense since they are in parallel. See, this is and this is parallel connection. No?
yes, sir.
So the total resistance 1 by R equal to 1 by S plus 1 by RG. So 1 R equal to I can write S into RG by S into RG by I can write S plus RG. So
Yes, sir.
this gives the total resistance R equal to. Okay. Now what I can write? What I can write here? R equal to, since we have this is a formula, okay, which after LCM this. Now the substitution, if you see, uh, R equal to S into RG in the sense 0.8 into 0.2. How much?
0.16
0.16
by 1.
by 0.2 plus 0.8, 1.
1.
Okay. So the total equivalent resistance I can write 0.16 ohms.
Yes,
Is
sir.
a total resistance which is combined in the an ammeter circuit. Okay.
Yes, sir.
So this is one of the example. Same like whenever coming to the with respect to voltmeter, it comes voltmeter. In the voltmeter, always what we are doing, we will enhance the resistance of galvanometer. Then it acts as a voltmeter. Remember, right? We will
Yes, sir.
enhance the resistance of galvanometer. Then it acts as a voltmeter. On that basis, we have to understand the concept and we have to apply that, right? So
Yes, sir.
next, s- shall we start the next lesson? Which is what is the lesson? Is that
Magnetism
magnetism?
and the
Yeah, exactly. It is first magnetism. What do you mean by magnet and all? We get to know that. For that, what I'll do? Give me a minute.